Hey everybody, Mr. Klein here. We're going to count this as a hat. It's fun, right? All right, well today we're going to talk about something called the Intermediate-Value Theorem. It's kind of cool because it's related to something that's going on in the news right now. There is this idea out there in the world of traffic, like traffic patterns, driving on the road. And it's that the speed limit doesn't really work anymore, right? So if you think about a speed limit, a speed limit is like saying, I don't know, let's take an example, Telegraph Road, Telegraph Road where they got that like big dip there. The speed there has to be less than or equal to 45 miles per hour. Well, simply not feasible, especially when you're going downhill. So there's this idea, comes out of California, Nevada, that kind of area. But I read in the local paper that Bloomfield Township is actually looking at testing this out. It's called a speed discontinuity. The idea behind a speed discontinuity is that where with a speed limit, your speed has to be less than or equal to 45 miles per hour. With a speed discontinuity, you're just not allowed to drive 45 miles per hour. So let's imagine that Bloomfield Township tests this out, and here you are in your car, and you're waiting at that light on Telegraph, and you get the green, and you are off. I don't know how fast you're going. You don't know how fast you're going, but it's not 45, I'll tell you that. It's 80, 90, 100. It's like you are the child of a cheetah and a racehorse, right? You are moving fast. And all of a sudden, woo, 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 here comes a police car to pull you over. So here's you. Here's your police car. Police officer comes over to you and says, I've been following you since you were stopped at that light. You topped out at 90 miles per hour. I am giving you a ticket. You say, oh, no. I read it in the paper. There's a speed discontinuity. 90 miles per hour is not equal to 45, right? Pfft, no, thank you. You tear the ticket up. Well, here's what the police officer says. Listen, I took Mr. Klein's AP Calculus class at Bloomfield Hills High School. And it seems to me that at the moment that the light started, let's call that 0, you were going 0 miles per hour. And then 2 minutes later, I pulled you over. And at that instant, you were going 90 miles per hour. And 45 is a speed that is intermittent, meaning that it is in between 0 and 90. So in order for you to get from 0 miles per hour to 90 miles per hour, says our friend, the police officer, somewhere along the way, and I don't know where it happened, bing, 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 you must have been traveling at 45 miles per hour. Here is your ticket. I know my rights. I will fight this in court, you say. You're in court. And fun fact, if you get a ticket and you challenge it in court and the police officer does not show up, I believe the ticket gets thrown out. But today the police officer shows up, and so you have to defend your actions to the judge. You say to the judge, Your Honor, this police officer says that since he caught me going 0 miles per hour at one time and 90 miles an hour at another time, I must have hit this intermediate value of 45 miles per hour. What the police officer does not realize is that my father is an executive at GM, and they're working on this new prototype of vehicle that can spontaneously transform speed. So in fact, I was going this fast until all of a sudden I jumped to this speed. Therefore, I was never going 45 miles per hour. All right, so let's tie this into the math, everybody. In the first circumstance, there had to be some time, we'll call it time x equals c, when the car was going 45 miles per hour. In the second example, that is not the case. What's the difference between the first example and the second example? Here's the answer. In the first case, the graph of our speed over time was continuous. And then in the second case, our graph was discontinuous. At least one point. I should add that in the first case, it was continuous on the entire interval from 0 to 2. All right. So this brings us to an idea called the intermediate value theorem. Let me explain what the intermediate value theorem means. I'm going to draw a picture first, and then I will write the theorem out for you. The theorem works like this. It says, suppose we have a start time. We'll call that A. And we have an end time, and we'll call that B. Further, let's say that we know this point. So we know what y value we start at, right? A is connected with f of a. And then we also know this point right here. So if this is B, then the y value associated is f of B. And then it says, let's assume that the curve is continuous on the interval that connects those 2 points. Then, according to the mean value, according to the intermediate value theorem, if y is some value that is between f of a and f of b, so it's on this interval right here, then it is guaranteed that somewhere on this interval down here, from time A to time B, or another way to put this would be from x equals A to x equals B, there must be some x value where if you plug it into the function, you will get y. So in the case of this function, it's right here. So another way of thinking about this is that the function has to hit all of the values between f of A and f of B somewhere on this interval. Okay, now we call this instant, or this x value, x equals c. And therefore, y would be equal to, you plug c into the function, you get f of c. Okay, that's a c, not super clear. So here's the statement of the intermediate value theorem. It says, if we meet two conditions. First condition is that f is continuous on the interval from A to B. Second condition, y is a number between f of A and f of B. So if we can guarantee those two conditions, then we can state this conclusion. There exists sometime x equals c such that c is between A and B. So you look right here, c is between them. And if you plug c into the function, you will get this y that we were talking about up here. Okay. These are called the conditions of the statement. This is called the conclusion of the statement. All right. Hey, now let's just say a quick word about these two conditions. Why do we have to have these conditions? Well, let's talk about the continuous one first, right? We saw that here, when we broke the continuity condition and we added this step discontinuity, it was no longer true that it had to be 45 miles per hour. So that's why we have to have this condition. The second one says that our y value has to be between f of a and f of b. Here's why. So as a quick example, don't write this, but just look up here. Imagine that we picked a different y value that wasn't between them. It might hit the interval, like if I picked a y that was down here, boom, 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 boom. Sure, I can see there's two different c values where that would be true. But also, if I pick a y value up here or further down here, neither of those are going to hit the curve. So we can only guarantee that we will hit all the y values on this interval right here from f of a to f of b. And that's the intermediate value theorem. The end.